Sorry doktor, saya baru masuk doktor.
Okey, baru masuk. Tak apa, nanti boleh tengok. Kita sekarang ni tengah travel dalam transmission line, lepas tu dalam tower dah. Dah masuk tower, dah sampai ke bawah tower.
Oh, okey.
So, kita tengah calculate reflection coefficient dekat bawah tower, dah habis. Jadi, kita akan follow the surge. What happen is, the surge from lightning strike the transmission line, dia akan ke tower dan masuk dalam tower. Lepas tu turun ke bawah, and then at the bottom of the tower, it got reflected again. And then dia akan travel balik naik atas. So awak kena imagine macam tu lah. So now, bila dia naik ke atas, kita akan kira dia punya reflection pula ke atas tower tu. Tak apalah, saya tunggu yang lain. Awak baru masuk sekarang kan?
Ya doktor. Saya baru baca WhatsApp tadi.
Oh, yalah. Tapi tak apa, nanti boleh tengok. Dan kalau tak apa,
Okey.
buka, tapi
Boleh.
okay. So saya ingat saya akan sambung for the last part. Ada lebih kurang 20 minit saja lagi. Tak apa. Kalau kita tadi kita dah ikut, kalau tengok saya punya slide ni, the situation is like this. The lightning striking a point here, and then it travels to the top of the tower. Okay, some of it will be propagating towards the other line, and some of it will go down the tower. And the one that goes down the tower already arrived at the bottom of the tower. And at the bottom of the tower, it will get reflected. The reflection is alpha 2, and the transmission into the tower footing resistance is beta 2. The one that got reflected is given by this formula. It's given here. This is the formula given by that formula. And the reflected surge akan travel towards the top. So the situation is like this. V reflected ni will have a voltage alpha 2, beta 1, Vs. Dia akan travel towards the top of the tower. So this is your Z1. Z1 is now Z tower. Bila dia sampai dekat atas tower tu, dia akan nampak dua wire. Okay, like that. Sebab this is connected. So for the surge, that is actually reflected like this, given by this voltage, alpha 2 beta 1 Vs, akan travel towards the top of the tower. At the top of the tower, when it arrives, it will get reflected. It will get reflected again. And this one will have a coefficient alpha 3. So the voltage is alpha 3, alpha 2, beta 1, Vs. But some of the voltage will also got transmitted both ways lah, beta 3. The voltage is beta 3 multiplied by V incident, which is alpha 2, beta 1. So for this case, we have the situation like this. So we have Z tower, we have Z earth on the left, Z earth on the right. And the discontinuity is at that point. And we're going to have alpha 3 as reflection coefficient. And beta 2 as our transmission coefficient. Oleh kerana ada dua ZE there, we have to combine as before. So the two ZE will become Z equivalent. And Z tower is Z1, and the discontinuity point is in the middle there. So we have alpha 3 and beta 3 like this. Okay? So Z2 in this case is given by this formula. Z1 is actually Z tower. Alright? Any question? This is the formula for alpha 3 and beta 3. Finally, we can actually complete the Bewley lattice diagram. Okay, like this. Let me go through the Bewley lattice diagram. We have original voltage traveling from the transmission line, the point of strike, X distance. So the strike at X distance from the tower, it will reach the tower top within a certain time based on this formula. The speed X is actually X is actually the speed, C, or velocity, multiplied by time travel. So time travel, how long it takes, multiplied by speed will give you the X descent. Or the time travel, T, let's say T1, is equal to X divided by velocity. Okay, so you need to use this formula later on. How long it takes from the point of strike to the tower? It's actually X divided by velocity. So the distance divided by the velocity. It could be speed of light. Now, when you reach, you start your clock. You can start from zero from the point of strike, but here I start the clock when it reached the tower. So my clock here start at t equal to 0 when the surge represented by Vs or source Vs reach the top of the tower given at the point 1 there. So this is the tower equivalent with a height h. This is the tower top. This is the tower bottom. So it reached the top at time equal to 0, neglecting T1. So when it reached the tower top, it will get reflected, right? As we have discussed. And the reflection voltage is alpha 1 Vs. So where does the reflection? It goes back to the right because we're coming from the middle to the left. So it goes back to the right of the transmission line. So it got reflected, but some of the voltage also got transmitted. Transmitted into two things, to the wires, earth wires on the left, as well as into the tower. But what we are showing here, the one that goes into the tower, actually is the same, the one that goes into the transmission line on the left, because it's beta 1 Vs as well. But we are looking at the tower now. So beta 1 Vs is actually the voltage that goes into the tower. And then it will travel a certain time until it reach. So T here is equal to H divided by Cs. Cs being the speed of propagation inside the tower. Now, when it reached the bottom of the tower, it got reflected again by alpha 2, as you can see there. Alpha 2 beta 1 Vs is the voltage. And transmitted into the tower footing resistance, beta 2. Now, beta 2, because we already have beta 1 at the top there. So that happened at T. Then the one that got reflected, alpha 2 beta 1 Vs, will travel to point 3 at the top of the tower. At time 3, or 3, at time 3, which is 2t, or the point 3, if you like, in time, we have another reflection, which is alpha 3. So we have alpha 3 there, multiplied by the incident voltage, which is the reflected from the tower bottom, as well as transmitted voltage, beta 3 multiply the voltage got incident. And this goes on, the reflected voltage here will travel to the bottom of the tower again. And it will reach the bottom of the tower in T, therefore the time now is 3t, and got reflected again. So this way you have alpha 2 again. So alpha 2 now twice. So whatever voltage that incident, so this is incident voltage, is given by this formula for that case, for the point 4. So incident voltage multiplied by alpha 2 will give you the reflected voltage. And the one multiplied by beta 2 with the incident voltage multiplied by the beta 2 will be the voltage that got transmitted into the tower footing resistance. So you know, every T at the tower footing resistance, there is voltage injected into it. For the first one, T, and then 2T later, you have another one. And 2T later, at 5T, you have another one. At the top of the tower, you have voltage transmitted at 3, at 2T, at 4T, as well as 6T. So you see, this is called Bewley lattice diagram. Any question here? Anyone have any problem? You had to draw this Bewley lattice diagram in your for your understanding, and of course in your exam as well. So any question? No question? Anyone? Okay, let me repeat again. Okay, let me wrap this first. We have what we call voltage, Vs. We have already calculated, generated at the transmission line. This voltage will travel to the tower, nearest tower, if you like, that we have already identified. Actually, it travels everywhere, but we just consider one surge that goes to the tower. And that voltage Vs will get reflected at the top of the tower, as well as transmitted into the tower. We just consider the one that goes into the tower. There is also another transmitted voltage for the line connected after the tower. But we just consider the one in the tower because we want to compute voltage at the top of the tower. So the one that goes into the tower is the same as the voltage that propagates through the other end of the earthing wire. So beta 1 Vs get into the tower, will travel towards the bottom of the tower, and it will reach there in time t. Of course, we start the clock when the tower first received the surge. Remember, the time to peak is always the same. Okay, so this is very important. So if Vs is of this shape, T front, and this is 1 per unit, Vs, let's say that's 1 per unit, beta 1 Vs will look exactly the same, except it's not 1 per unit anymore. It's still Tf, but it is beta 1 Vs. It could be 0.5 per unit, depend on beta 1. But the shape is the same, if you like. The time to front or time to peak, T front, or time to peak. I think we use time to peak, right? Or T peak is still the same. Yes, so this is important. Only magnitude change, it can also be negative. Remember, it can even be negative as well. But still, the time to peak remains the same, negative. It can be like some value, but negative value. Or it can be magnified. Remember this. Now, how do I know the value? The value is given here. All these are the values. Now, you need to remember what I have said just now. At any point in time, let's say at point 1, the voltage remains the same. The incident plus the reflection, this one, incident, reflection, is the same as the voltage that got transmitted. So V1 is actually Vs plus alpha 1 Vs, but it's also the same as beta 1 Vs. You can choose. So if I were you, I would choose the second line, which is shorter, beta 1 Vs. Okay?